All right, so we're back. Class is going to be back to normal. I looked at the little poll that I put in the chat, and let's see. Okay, so everyone, well, I say everyone, but at least 5 people, the 5 who voted, wanted class to go back to this style of, having synchronous meetings with just lecture material. So that's good, because that means That means that at least 5 of y'all feel confident in the material, and like you don't need our meetings to be like personalized tutor sessions. So that's good. Okay. So what I'd like to do today is recap the bit of 3.1 that I already covered in the video. 3.1, as well, I say the little bit I covered, it's a 2-hour long video, which is great. Like, being able to get that much of this section, it's a tricky section, to be able to get that much across without using up lecture time is really good. Really good for you guys, because it's more work for me, but that's okay. It's good for you guys because you get to see way more examples. Okay, so I'm assuming you've all watched the 3.1 video. So I'd like to recap the section 3.1 video lecture. There's still more to cover in 3.1, believe it or not, but I've done the brunt of the work in that video. So, so with some examples here. So, and I'm just, I don't want to number them as official examples because that's going to come when I start the new stuff. So I'll just number this number 1. What do we want here? Let's find, given f of x equals 5x squared minus 30x plus 49. What are we doing with this quadratic function? So to remind you, 3.1 is about graphing quadratic functions. So how do we graph quadratic functions? What did we look at? Well, we want vertex. We want x and y intercepts. So we're going to find the vertex, find the x and y intercepts, find the. Now we did not talk about that, or I did not talk about this in the video lecture. This is going to be a new thing. Find the max or min. Well, let me write it. Maximum or minimum value. Oops, minimum value. So we're gonna talk about that in more detail. And D, finally, I also want us to be able to sketch a graph. So this is a little bit different than the examples I set up in the video, because in the video I say vertex, xy intercepts, domain and range, and then a sketch. Okay. So let's find the vertex. So how do you find, so for part A, how do we find the vertex? We have to put the function in standard form. We have to put it in so-called standard form. So recall that to do this, we take a function from ax squared. So this, like this form that we have up here, which is going to be like the given form. Most of the time it's written ax squared plus bx plus c. You've got a, b, and c. In this case, a is 5, b is negative 30, c is 49. And we want to get to a function of the form a times x minus h all squared plus k, where Why do we want this form? Well, because once it's in this form, we can easily read off h comma k is the vertex. We can easily find that vertex once we get it in this form. Now, getting it into this form is like that's the big problem in this section. Getting from this form, like the given form here, to something in this form. So how do I do that for this function f of x equals 5x squared minus 30x plus 49, right? How do I do that? Okay, so without reconstructing everything I went through in that video lecture, the first thing I do is I say, well, if there is a non-1 leading coefficient, so a leading coefficient right here that is not just a 1, then I need to factor it off. But I only factor it off of the first two terms. So my first step, since I have a number up front, a leading coefficient that's not a 1, I have to do this as my first step. I have to factor that 5 off of the first two terms. So pulling it off the first term literally just means like just moving it off, right? Now the second term will become a 6x. There we go. Because pulling a 5 off of negative 30 leaves you with a negative 6. And I'm only factoring it off of the first two terms. The 49 is just out here by itself. Now what I do is I think about, so this next step is where all the magic happens. Oops. I think about how can I make this thing inside here into a perfect square trinomial. That's what I'm trying to figure out. I want to turn it into a perfect square trinomial, because if I can get it as a perfect square trinomial, then I can write it in this form, this x minus h all squared. I can write it in this form. Okay, so how did we do that? We take the linear coefficient, which is the negative 6, we write it off on the side. We say negative 6, you cut it in half and you square it. Linear coefficient divided by 2 and squared. Okay, and what am I going to do with that? So let me just compute what that is. It's 9, right? So negative 6 over 2 is negative 3, and then squared is 9. This is the number that gets added inside the parentheses in order to make this function, or this part inside here, a perfect square trinomial. So I say x squared minus 6x, and then inside I say plus 9. I add a 9 inside the parentheses in order to force this part right here to become a perfect square trinomial. And I also need to bring balance to this. I can't just, I can't just arbitrarily like add 9 to a function and expect it to be the same function, right? I have to bring balance by also subtracting a 9. But recall that in this case, when you have a number out here, right? This is one of the trickier ones, right? This is one of the trickier ones when you have a number out front that's not a 1. But when that happens, I have to account for that number. So instead of just subtracting a 9, Kimberly, do you recall what I would want to subtract here?
I'm struggling to remember what we did there.
So I added a 9 inside, right?
Yeah.
But if you expanded this all out, like if you sent this 5 to all three of these terms, technically, what did I actually add?
45.
Right. So that means out here to bring balance, I subtract a 45. That's one of those tricky things. Thank you. That's one of those tricky things about these kinds of problems that have a something other than a 1 leading outside. The leading coefficient is not 1. Is you have to remember that when you're bringing balance to the equation that you don't just subtract 9. That's a really easy thing to forget and just write plus 9 minus 9 and to go on to the next step. But you have to remember to account for that number out here that's going to make that bigger than 9, right? So that's why I'm subtracting 45. Okay, now the next step is to say, okay, this is now perfect square trinomial form. I know that now it can be written like this, like x plus or minus something inside. How do I know what it is? I go look at this step right here. That tells me what number gets written right there. I mean, also you could just think about how does this thing factor, right? If you're comfortable with factoring these things, then you know that this would factor into this form here, it would compact into this form. But as a little trick, when you're writing this next step, it's always going to be x, it's going to be some parentheses, two things inside, squared, and it's going to be x and then either plus or minus some number. And whether it's plus or minus comes from right in here, and what the number is comes from right in here, this step right here. Off on the side, this step right here, the number right here gets stuffed right there. Okay, then out here, I just do that arithmetic on the outside. That's the easy part, plus 49, positive 49 minus 45 is a positive 4. That's it. This is like the trickiest thing in this section, getting from this form to this form, and now it's done. So how do you get good at this? You drill problems, right? You do lots of problems. Now, I'm still not done with part A of officially, because part A was to find the vertex. But at this point, once it's written in this form, I can easily identify the vertex, right? The vertex is going to come from the numbers that are the number written inside here will be the x coordinate, except I have to flip the sign. So if it's a -3, then 3 goes there. And the y coordinate is coming from the thing that's added or subtracted on the outside, which is this 4. So I have a vertex at 3, 4. So the idea is once you get it in this form, the vertex just pops right out. All right, let's do part B. Part B is the x and y intercepts, finding x and y intercepts. Now, this will seem much easier, at least relative to this first part. So to find a y-intercept, you simply set x equal to 0. That's your work should look like this, right? If you're inputting a number into the function, then you put that number right there in the function. And now at this point, I can use either form of the function. I can use the original form, or I can use the standard form that we found. Let's see, does anyone have any idea about which one would be easier to use for this particular case? So let's see, Makira, what do you think? Should I use the original form or the standard form? Or do you think it matters?
Probably the standard
one. I see you unmuted, but I didn't hear anything. Let's see, how about Aviana?
Could you use standard form?
Yes, you could, and that would look like 5 times 0 minus 3 all squared plus 4. So what's going to happen here? Let's see, 5 times -3 all squared plus 4, and that's going to be 5 times 9 plus 4, and that's going to be 45 plus 4. And then I end up with 49. Now, I just want to point this out. For finding the y-intercept, if the number, or sorry, not the number, if the function is written in this original form, then when you plug in x equals 0, all you get is that constant number, right? So it's easier to use the original form here, because when you plug in x equals 0, these terms just go away and you just end up with 49. Now, if you choose to use the standard form, you see right here, the 49 comes out, right? It's fine. And it's just arithmetic, in between. But if you want to skip this, then just go back to that original form and look at what the constant is. That constant will be the y-intercept. Now, x-intercepts. We set the output equal to 0. So instead of setting input equal to 0, we set output equal to 0. Now, in this case, you will want to use that form that we built for sure. It's good for solving this. So we say, here's the function. This is f of x. This is the function in its new form. And we're setting it equal to 0, and we're solving for x. We're going to try to solve for x. So I'm just going to start unpacking x, right? So I have first a -4, right, on the other side, just scooting the -4 over, or rather scooting the 4 across the equal sign, right? If it's positive here, it becomes negative on the other side. I'm going to divide by 5, because this 5 is attached to this chunk here by multiplication, so I'll undo that by dividing. Now I'm still trying to unpack x, right? And the next thing to get rid of is this squared term outside. So I'm going to take a square root on both sides. Whoops. And remember that when you take a square root in an equation like this, you've got to introduce that plus or minus symbol. So that's plus or minus square root of -4/5. X minus 3 equals plus or minus square root of -4/5. But this is a problem. Taylor, do you remember why this is a problem? Like why we can't actually go any further? It's something to do with the square root.
No.
Because there's a negative under the square root, we have now fallen outside of the real number system. So in other words, here's how to say this. We cannot take square roots of negatives. We cannot take square roots of negative numbers. Now, well, here's the deal about that. You actually can, of course, we've done it in section 1.5. We looked at complex numbers, right? Square roots of negatives make you fall into the strictly complex numbers, and you can do it. People do it all the time. Engineers do it. Electricians do it, right? Complex numbers exist, but in the case of what we're trying to do here, we're trying to find where this function crosses the real x-axis. And when we're doing that, if this happens, then that means it does not cross the real x-axis. When I say the real x-axis, I just mean that horizontal x-axis, right? The number line on the coordinate plane, the horizontal axis. Because that's what finding an x-intercept is. You're finding where the function intercepts that horizontal axis. If this happens, then we say there are no x-intercepts. Oh goodness, I butchered that. Okay, there are no x-intercepts. Okay. Oh, back here, I didn't actually write down the y-intercept. Like officially, the y-intercept is a point, right? So back here, over here, the y-intercept is 0,49, right? I mean, I found, that the x value is 0 and the y value is 49, but I didn't actually write down the coordinate point. I should have done that. The actual x-intercept is not 49. It's a coordinate point, 0,49. Just technicality there. Okay, so that was part B, finding intercepts. Part C, I asked to find the maximum and minimum value. So let's see, what do we have so far? We have that f of x. We have f of x in this form. We have 5x squared minus 30x plus 49. That was given to us. We also have that we can write it as 5 times x minus 3 all squared plus 4. We know its vertex is 3 comma 4. We know its y-intercept is 0 comma 49, and we know its x-intercepts, there are none. So I'll say NA, not available, not applicable. And now we want to do part C, which is to find the max and min, or max or minimum value, maximum or minimum value. But I'd actually like to do part D first. I'd like to do the sketch and then look at part C. So I'm going to say C and D together. Okay, and I'm going to do it right here. So if I'm going to sketch a graph, then I need to have a coordinate plane. Now, as you're sketching, you should be thinking about, where is this parabola? Where is this parabola? Well, its vertex is at 3 comma 4, so I'm definitely going to need to graph 3 comma 4. And that tells me that at least the vertex is over here in the first quadrant at 3 comma 4. I'll just put some points over here too. So there's 3, and then here's 4 up here. I also know that its y-intercept is all the way up on the y-axis at 49. I'm not going to be able to graph that, right? 49 is like, oh, so, you know, way off the page. So what I'm going to do is graph its vertex, which is 3 comma 4. There's its vertex right there, 3 comma 4. What else do I need to know? Since I don't have any x-intercepts, right? It doesn't cross the x-axis. It doesn't cross this horizontal axis. So this is x, right? And this is the y value here, the output value. I know that this graph is pointing up, right? I know that it's pointing up. If it doesn't have x-intercepts, that means from here it must go up. And also I know that because that leading coefficient is positive, that tells me that this graph is pointing up. Moreover, from last chapter, I know that this 5 outside is going to be scaling this thing, or rather stretching this thing up vertically by 5. So it should not be like a really wide parabola. It should be a really narrow parabola. So something like this. Okay, so there's my sketch. There's my sketch. Again, I can't really graph the y-intercept. It's too big, right? I would need a huge piece of paper or probably just a graphing calculator of some sort to be able to see that y-intercept. Okay, now part C was to find the maximum or minimum value. So I want to talk about that a little bit. Does anyone have any idea about whether this graph has a max or a minimum? Let's see, Kimberly, does this graph have a maximum value?
I think so.
What do you think its maximum might be?
I'm not sure about that.
Probably because it actually doesn't have one.
Okay.
Right? Yeah. Why though? Why? Because it's infinite going up, right? So if I told you its maximum is 1,000, well, then you could say, well, no, it's not, because I can just go higher than that because the graph keeps going higher. But does it have a minimum value? Like, does the parabola ever, well, does it have a smallest value? What do you think, Kimberly?
Yeah, would it be the point that it's on?
That point, right? Exactly.
Right.
Thank you. Good. Okay. So let's write some stuff down about this maximum minimum thing. So Kimberly is right that the minimum is happening at the vertex, but how exactly, do we say this? So let's see. I'm going to start over here. The minimum value is the y value y value of the vertex. Let's just say it like that. So the minimum is, now how can we write this with function notation? I could just say 4, right? I know the vertex is 4, I could just say the minimum is 4. That's the lowest value it's ever going to hit. It never goes below 4. Like if I say, when does this function hit a y value of 2? Like down here at y value of 2. Well, it doesn't, right? It has a minimum. It has a minimum because the rest of it is pointing up. It's not bounded going up, right? It never has a maximum, but it does have a lowest point. So how do I write that down here? I could say the minimum is 4, but what we like to do when you're talking about maximum and minimum values, you're really talking about the y value, the output. But we like to be able to also put in the information about the input value, where the minimum value happens or where the maximum value happens. So the way we write it down is we say f of something equals 4. And Makira, what x value do I put in here that gives an output of 4 according to the vertex? Like, where does that vertex happen?
I'm not sure.
Oh, hang on, let me turn you up because okay. So what x value is the vertex happening at?
Oh, 3.
Yes, there it is.
Oh, okay.
Yep, good, thank you. So this is what's happening with maximum and minimum. A parabola is always either going to have a minimum or a maximum value. And if it's pointing up, it specifically is going to have a minimum. If it's pointing down, then it's going to have a maximum. And we like to say, when you actually write it down, we like to say it like this. Even though the real answer is 4, we like to also put this here so that we know where the maximum or minimum is happening. And why is that? Why do we write it like why do we care? You know, if the answer is just 4, why not just write 4? Why do we have to write f of 3 equals 4? I think that's just kind of like become standard because this maximum minimum stuff, finding the max or minimum of functions, you could group that into this thing called optimization. And that is a huge area of applied mathematics. So we're getting now into stuff that's not just math for fun, right? This stuff happens in real life where people look at maximum and minimum values of functions, even quadratic functions like we're doing here. So if a person was modeling like their profit or something like that with a parabola, and the parabola has a maximum value, they're going to want to know not just what the maximum is, but where it happens, right? They don't want to know just how much maximum profit can I make this month. They also want to know how many items do I need to sell in order to maximize my profit. So that's why we tend to write it not just with what the minimum or maximum is, but also where it happens. All right, let's do another one. And I spent a lot of time on that, but I think probably you guys won't complain. I think that's it's a good one to look at. So let's do another quicker one. So I just called that number 1 for review. So this is to like recap. There's so much to say in this section. I mean, we could spend like the rest of the semester really talking about this stuff, or at least another few weeks, but we won't. We'll just talk about it for probably today, maybe a little bit on Wednesday. We'll see how it goes. All right. Same instructions as number 1. Let's do this. So part A, f of x equals negative x. I'm just rewriting it here. Now, this is again one where the leading coefficient is not just a 1, it's a negative 1. So I factor that off. Just like the 5, I factor it off of the first two terms. Now, if you haven't watched that video for 3.1, obviously, definitely you're going to want to go watch that like as soon as possible. You're also probably pretty lost right now. Just know that when I am building up this process that I'm working through right now, which is the trickiest part, right? I build that up very slowly in that video. That's why it's 2 hours long. So don't panic. I mean, you know, still obviously go watch it, right, and take notes on it and everything, but don't panic if you can't follow this part right now, because these are trickier versions of, these are like the trickiest kinds, and I build up to them slowly in that video. Okay, I need to decide what gets added or subtracted inside the inside here, and then what gets subtracted outside here. So off on the side, I take my linear coefficient, I cut it in half, and I square it. But what is my linear coefficient here? Aviana, do you know what the technically, what is the coefficient attached to this x right here?
I need a 1.
Not just a 1, that you're right, it's a 1, but also it's a negative 1. So that's important. I mean, the negative isn't going to matter in the end right here because I'm going to end up squaring it, so it's going to end up positive anyways. But in this, in the step where we decide what gets stuffed into the parentheses after it's factored, that negative does matter. And by the way, why did it become negative? Because I pulled a negative off of the first two terms, effectively changing both of their signs. So the first term becomes positive and the second term became negative because I pulled a negative off. All right, so right here, well, I can just go ahead and actually square it and say 1/4. Nothing to simplify, like as far as like the fraction inside, right? -1/2, and then square it gives me 1/4. So that's what gets added in here. And what do I write out here? So again, a little tricky here. I should, like, if there was nothing going on up front, I would just write -1/4. But since I need to account for whatever's happening out here, what actually happens is that this negative applies to this 1/4. The negative applies to this 1/4, meaning that what I'm actually doing in here is I'm actually subtracting 1/4. So in order to bring balance, I have to add 1/4 on the outside. Which is very strange, right? But that's what's happening. I have to think about what did I do here so that I can think about how to bring balance out here. All right, so inside the parentheses, the minus sign still hanging on the outside. Inside, I know it's going to be of this form without even thinking. I know it should be of this form. How do I know what gets written right here? I come over here and I look at what's in this parentheses before I squared it. So -1/2, so that goes right there, just like that, just like that. Now outside here, fraction addition, that's going to be 8/4 plus 1/4 gives me 9/4. All right, and there it is. It's in vertex or standard form, and now we can identify the vertex. So my vertex is 1/2, 9/4. That's okay. It's fractional. That's all right. And if you'd like to have it as a decimal, that's 0.5, 2.25. We tend to like to have it as decimals. For the purpose of graphing, right? You may be more comfortable knowing where that is on a coordinate plane versus where 9/4 is, right? All right, so we found the vertex. Fractions are involved, but that's okay because we know how to deal with fractions. We're also going to want the x and y intercept, so let's do that. Y-intercept, we are setting x equal to 0. I see that if I set x equal to 0 up here, if I remember that the fastest way to get it is to use the given form, all these terms zero out and I just get a 2. I just get that constant 2 at the constant term there. So my y-intercept is 0, 2. My x-intercepts, now last time I didn't have any. Will I have any this time? Let's see. So I'm going to take, I'm going to set f of x equal to 0 and solve for x. Solve for x. So I have, where is it? Negative of x minus 1 over 2 squared. So I'm just writing down the standard form and I'm going to set that equal to 0. Because there it is right there. Set it equal to 0. Now I've got to solve this. So fractions, right? But don't panic. Let's see, what do we do? This is positive 9/4. I scooted across the equal sign. It's going to become negative 9/4. Now I need to write the rest of this thing. Okay, so I've scooted the 9/4 across the equal sign. Next thing I'm going to do is say, well, look, they're both negative. Negative out here, so I'll just divide both sides by -1, effectively making both sides positive. That's nice. Okay. Now I'm going to take a square root on both sides. I'm going to take a square root on both sides, which unpacks this side from its square, right? This whole thing is squared, but I'm taking a square root on both sides. Don't forget the plus minus 9/4. And what does square root of 9/4? Oh, you're good, Maya. It's recording, so you're good. What does square root of 9/4 reduce to? They're both perfect squares, so it reduces to square root of 9 is 3, square root of 4 is 2. So that's nice. That's nice. And then x is equal to, so I go over this in more detail in the 3.1 video as well, that when you reach this point and you're solving this last step, I'm adding 1/2 to both sides. I'm going to stuff that right there and then have my plus or minus term written. So it's going to work better like this instead of trying to add 1/2 on this side. It gets a little confusing. So you stuff it right there between the equal sign and the plus minus sign. That just keeps you from running into weird issues with the notation. Now here I can actually go ahead and split these and solve these because this is just like fraction addition. I can do that. There's the plus one, right? So this is two answers, 1/2 plus 3/2 and 1/2 minus 3/2. So I'll solve each of these individually. This one gives me 1/2 plus 3/2 is 4/2. That's 2. Nice. And now the other one, x equals 1/2 minus 3/2. That's going to be 1/2 minus 3/2. That's negative 2/2. So that's -1. So I have my two x-intercepts at 2, 0 and -1, 0. Good. Quick note, another way to find x-intercepts is to take that original form, f of x equals -x squared plus x plus 2, and to use the quadratic formula, (b plus or minus b squared minus 4ac all over 2a. You could do that as well. That might be a good thing to try. If you like formulas better than processes, then you can use the original form they gave, where, by the way, a is -1, b is 1, and c is 2. Plug those into this. Clean it all up, you'll end up with the exact same two solutions. You should. Okay, so the last thing is to graph it and to find its max and min. So again, I'm going to do C and D together because they kind of go hand in hand. Let's see, how do I want to graph this thing? It's got really nice x-intercepts. It's got a nice y-intercept. Its vertex is fractional. So let's see, I can use a reasonably sized graph with, I'll put 1, 2. I'm making my tick marks wider because this one doesn't go crazy, right? It's everything's around like 1 or 2. In fact, I'll go out to 3 just to, there we go. All right. Vertex is at 1/2, so 0.5 for x, and then 2.25 for y, so I'm going to say roughly there. That's my vertex. I have a y-intercept at 0, 2, so that's x value 0, so somewhere along the y-axis, and it's at 2. There's my y-intercept. So right next to the vertex, right? Hang on. Yeah. All right, there we go. Okay, then my x-intercepts were 2, 0, so that's all the way over here, and -1, 0, which is right there. So I'm getting an idea of the shape of the parabola here. Clearly it's pointing down, which I already knew because its leading coefficient was negative. Nice. Now let's talk about its max/minimum value. The last one, here it is, the last one had a minimum value at the y value of the vertex because it was pointing up. This one has a maximum value because it's pointing down, right? It has a highest value right there. It never goes above. Is it bounded below? No, it's infinite going down, but it has a highest value. So the maximum value, it still happens at the same place at the vertex. It's just now it's a maximum instead of a minimum, is the y value of the vertex. And we say it the exact same way, like in that, with that f of blah, blah, blah notation. So the maximum is f of something equals something, right? And where does this come from? It comes from the vertex, which I'll write down again. I'm going to write it in fraction form. It was 1/2, what was it? 9/4. 9/4. There we go. 1/2, 9/4. So we would say f of 1/2 equals 9/4. There it is. That's the maximum value. Okay, so that pretty much is that's taking like almost all the class. Let me write down the facts about these max and mins, and then, ooh, what just happened to my computer? Okay, all right, we're good. I'm going to write down a shortcut and for finding the max and min, and if we have time, we will have time to run a couple quick examples of that, and then next time we will look at, so I'm still not done, I'm going to use every minute that we have here, but next time we'll actually look at some modeling with real life problems, because I said, you know, I went on a tangent about how this stuff is really important in real life, so I'll show you at least one example of that. Okay, so here it is. For f of x equals ax squared plus bx plus c, the maximum or minimum happens at, so I'm not telling you what it's going to be, I'm going to tell you where it happens, and you have to be able to evaluate it. That's how this goes. At -b/2a. That's the x value where the maximum or minimum is happening. And what are these letters, -b/2a? They're coming from the coefficients when it's written in this given form here. All right. And also you have to be able to tell me if the value is a maximum or a minimum, but that's just going to be, here, I'll write that down real quick. It's a maximum if that leading term is greater than 0, that leading coefficient, and it's a minimum. Nope, I have that backwards. No. Sorry, it's a maximum if the term is negative, the leading term is negative, and it's a minimum if the leading term is positive. Like the last two we just did. The first one we did, the 5 was positive and we had a minimum value. The one we just did, number 2, it had a negative leading term, so it had a maximum value. So this is officially example 1 for this lecture. Let's find the max or min of each, maximum or minimum of each. Part A, f of x equals x squared plus 4x. So that doesn't have a constant term. And part B, g of x is negative 2x squared plus 4x minus 5. So what do? I figure out what is negative b over 2a. I'm going to figure out what that is. That's going to be some x value, and then I'm going to plug it into the function. Okay. Well, what is b here, and what is a? So let's see, Maya, what would the value b be in this case?
Would be, is that a 1 or a B? That's a
So
B.
what value is b in this?
It'll be negative B.
What number is it?
1.
Well, that would be the a term, right? Because a here is 1. So then b would be 4.
Oh, 4.
Yeah. Yeah. So it's coming from this form. If it's given in this form, ax squared plus bx plus c, then we have to be able to identify a, b, and c. Well, really just a and b. C doesn't matter for finding this maximum. See, c is not involved here, the constant term, but we got to be able to at least identify what a and b are. Okay, so this is giving me negative 4 over 2 times 1. That's just negative 4 over 2, which is negative 2. That's where my maximum or minimum happens. So then I say f at negative 2, and I literally just plug it in. Squared plus 4 times negative 2. So that's going to be 4 plus, plus negative 8. I could have just said minus 8 there. That's okay. And then that's giving me negative 4. So I have either a max or a min at this point. There is a blank at f of negative 2 equals negative 4. And would it be a max or a min? Well, according to this rule, since a is positive, that leading coefficient, which is a 1, is positive, I have a minimum. So there is a minimum for this function at f of negative 2 equals negative 4. Okay, now over here for g of x, negative b over 2a. So let's see, Kimberly, what would this fraction look like here for negative b over 2a given this form here?
Negative b would be 4,
Mm-hmm.
negative 4, and then a would be, would it be 2?
It's the leading coefficient here. So
So -2.
yeah. So A and B and C are just coming straight from the coefficients in the function, and you keep their sign. Whatever their sign is stays. So it's not that like this 4 was positive, so it's not that I'm like flipping its sign. The negative is in the formula, right? So it's not, I'm not like manipulating its sign as I pull it down and saying, oh, if it's 4, then I write -4. It's the negative is just straight from the formula there. Okay, cool. So now I have -4 over -4, which is a 1. So then I'm going to say g of 1, I'm plugging in 1 into the function, evaluating this function at 1. One squared is just 1. 4 times 1 is 4. There we go. Got to figure out what this is. -2 plus 4 is 2 minus 5 gives me -3. So is there a maximum or a minimum at -3, or at the x value of 1 and a y value of -3? Is that a maximum or a minimum? Well, since my leading term is negative, I know my graph is pointing down, so this should be a maximum. Or I could also look at this rule here that says if the leading term is negative, right, less than 0, then that means I have a maximum. Okay. Cool. All right, so we still got a few minutes. Let me talk about the homework. The first few problems on the homework are about, for this section, are kind of they're like more conceptual, I think, than just actual calculations. Or they're more about the definitions of standard form and vertex and stuff like that. So for instance, let me work one and then that'll be it. Let's say just want to show you one of these. The graph of f of x equals 3 times x minus 2 squared minus 6. Is a parabola that opens blank with vertex at coordinate point blank comma blank, and f of 2 equals blank is the blank value of f. Okay, so how do we deal with this? This is from the homework, or at least similar to one of the homework problems, or a couple of them. Okay, first of all, this is a parabola. Sure, yeah, it's a degree 2, so it should be a parabola that opens. So does it open up or does it open down? Well, since I know that leading coefficient here, the 3 is positive, it opens up. Or I can say upward. Opens upward. Where is its vertex? So its vertex is going to be at 2, because I find the x value of the vertex by looking at the number in here, and I do flip that sign, right? That's where a sign flip does happen. And then I keep the sign on the y value coming from the number out here. So its vertex is at 2, -6. So that means f of 2 equal, well, it's right here. F of 2 equals -6. And is it a minimum or a maximum value? Is it a minimum or a maximum value? Any ideas? Imagine it opening upward. Would the vertex be a minimum or a maximum?
It would be minimum.
Yes, good. Yes, minimum. Good. So not only is the process of getting the function into this form and finding its intercepts and all that math important, but also this stuff where once you get it in this form, this is not really like computational at all, right? All the work is done for us. It's more about understanding the definitions, right? And also being able to go from a picture to these definitions and these concepts. All right, that's all I got for you guys today. On Wednesday, we'll finish 3.1 and probably start 3.2. You're good to go.